guys. For those of you who couldn't be here today, this is the second part of the lesson we started on Friday, and it's subtracting positive and negative integers. You will have homework at the end of the lesson. It's page 13 and 14, and are continuing the discussion on how addition and subtraction are inverse operations. All right, so what we're going to start with is these problems here, 2 through 5. The instructions are to write a subtraction problem to represent the situation, then to write the subtraction problem as an addition problem. Right? Then to model the addition problem on a number line, and then use the number line to answer the question. So our first question we have is that Adam buys 9 gift cards and gives 6 away. How many cards does he have left? So when you're talking about have left, right, it means we started with a number and now we have fewer. So the way we're going to write that as a subtraction problem, right, is to say that he had 9 gift cards, right, and then we subtract 6 cards from that. How many does he have left? And I know this is a very basic question, and you should be able to just say the answer. But what we're looking at here is more than just being able to know the answer. It's to see how you would get the answer on a more complex problem, but at the same time, know that you got it right because you already know what it should be. So let's take a look at that. It says, write it as a subtraction problem, then rewrite it as an addition problem. Now remember that addition and subtraction are inverse operations, so what we have to do is we're going to do what we tell you. We're going to keep the first number, right? We're going to change the operation sign, and then we're going to change the last number, right? So in order to rewrite this as an addition problem, we keep the first number, which is -9, so we're going to keep, which is +9, so we're going to keep that 9. We're going to change the operation to its inverse operation. Well, we've already determined that addition and subtraction are inverses, so if I'm subtracting, I need to change that to its inverse, which is to add, right? The third part of this is the second number has to be changed to its additive inverse. So change to additive inverse. And again, we want to start using that math vocabulary. So the additive inverse of 6, additive inverse means 2 numbers when you add them together you get 0. So 6 plus a -6 is equal to 0, right? So now we have 2 different equations. Now these 2 number sentences, 9 minus 6 and 9 plus a -6, are actually equivalent to each other. And the way we can see that, let's look at a number line. Draw the number line, right? We're going to go here, put a 0, -3, -2, -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So if I want to do this, right, 9 minus 6, right? That means I have 9, I'm going to take away a +6. I start at 9, put a dot there, and then I'm going to move my line 6 spaces in this direction. And if I do that, I'm going to end up right here, right? But I'm taking away a +6. So that's what I write on the line here, +6. The difference is when I'm doing this one, right? We know that they're inverses. So what that means is both of them should give me the same answer. So if I start at 9, right here, and then I'm going to add a -6. Well, when I add a -6, I go in this direction because I'm adding negatives, and I end up right back over here, right, at 3. But this time on the line it says -6. That's how I know it's an addition problem, because here I'm adding negatives to get to here. Here I'm subtracting a positive. Both graphs will look exactly the same. They'll start in the same place, they'll end in the same place. Your answer is going to be right here at 3, right? They start and end at the same place. This is a very basic problem, but it shows you how these two are inverse operations, and that's what we're looking for, to prove that they're inverse operations, right? And again, the graphs will look the same. The only difference will be the number on top of the line. One number, when you subtract, will be a positive, and when you add a negative, you'll have a negative number. But they're going to look exactly the same. And again, that's just proof that these are inverse operations, right? And that's how you use the number line, all right? So, same thing. We're looking at the next problem. The same kind of things going on, right? I'm going to rewrite that. I'm going to erase this, and I'm going to change these numbers on here, all right? So this problem, the second problem, we have a girl named Renee. And Renee's playing a video game online. And on this online, if she gets 25 points, she'll have a new high score. Right now, she has -5 points. So what I'm going to do, I'm going to go over here, and I'm going to start at -10, right? And I'm going to go by 5. -10, -5, 0, 5, 10, 15, 20, 25, 30, 35. That should be enough, all right? So if she gets 25 points, she'll have a new high score. She currently has -5 points. They want to know the difference. Difference means subtract. So right up here, I'm going to put a negative sign, right? I'm going to put a negative sign because I'm subtracting. Put a minus sign, not a negative sign, a minus sign, right? And then I'm going to do what it tells me. They want to know the difference between a high score of 25. So they want to know, that's our first number, 25, right? And then the score she currently has, which is a -5, right? So I need to find the difference between these two. Now, I can do the same thing. I keep, I change, and I change. If I keep 25, if I change this to a plus, if I change this to its inverse, which is a +5, I end up with 30, right? So the difference is 30. Can I prove that? Sure. I come over here. I can put a mark here at -5, which is what she currently has. I can put a mark at the 25, which is what she wants, and I can count. 5, 10, 15, 20, 25, 30, right? So if I did this on number line correctly, it would be 25 minus a -5. So in order to do this on number line, in this fashion, is 25, and I'm taking away a -5. So I'm going in this direction, it says -5. What that means is I'm subtracting a -5. This graph shows that it's subtracting a -5, and the answer is right here at 30, right? So this is graphing the equation, and this is just showing the difference between the two. This number and this number should be the same, right? So I proved this equation is correct by counting from this point to that point, all right? Next question is that Rob is trying to read for 30 minutes every Saturday, every weekend, right? Rob is trying to read for 30 minutes every Saturday. He only read for 20 minutes last Saturday, and he decided to represent that amount of time he was short of the 30 minutes as -10, because 30 minus 10 is 20. So this Saturday, he wants to make up the difference between the number of minutes he usually reads on Saturday and the number of minutes he was short last Saturday. So how many minutes will Rob need to read this Saturday? Well, we do the same thing. We look at this number here is not needed because that number is re-represented as -10. So numbers that we need to use are 30 and -10, right? So let's take this blue off of here, redo that line. We'll put 30 there, we're going to put 40 here, 45. We're going to go at 30. We're going to mark it. We have 30, right? minus, well, let's put it over here underneath the keep, 30 minus a negative 10. All right, again, if I keep it, I get 30. I change it, I change to a plus. I change this to its additive inverse, it becomes 30 plus 10, and that is equal to 40. All right, so 30 plus 10 is equal to 40. That means he has to read 40 minutes plus 10, right? He has to read 40 minutes this week in order to do 30 minutes every Saturday. All right, hopefully you can see that. Again, if you need to rewind it to make sure you understand it, I know I'm talking fast, but I only have so many minutes to be able to video on YouTube, and then, or they'll cut it. So in the meantime, let's take a look at question number 5. Question number 5. The temperature at noon is -4 degrees Fahrenheit. The temperature at 6 p.m. is -12. What's the difference between the noon and 6 p.m. temperatures? Again, whatever is said first, that's what we do. So they want to know the difference between noon and 6 p.m. All right? So that's the numbers we use. Noon, it was -4 degrees. Right? Then we have minus, and at 6 p.m., it was -12 degrees. All right? If we keep, we get -4, change, we get plus, change again, we get plus 12 here, just write 12. The difference between these two is 8. So what they're saying is that -4 is 8 degrees warmer than 12, right? Than -12, and that's true, right? So that's how you set these problems up. Always do the first number first, and then look at the second number. All right? So the back part of this, well, for you, the next page, is we're looking at some word problems, and we're going to do what they tell us. It says, Fran rewrites a subtraction problem as an addition problem. The addition problem she writes is -3 plus -4. -3 plus -4. All right? How can we use the number line to help you write -3 plus -4 as a subtraction problem? Well, we do the number line. Right? Again, number line. This goes 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5, -10. All right. How can I do this? Well, I start with the first number, right? My first number is -3, so I put a dot, right? And then it says I'm going to add a negative, right? So if I add negatives, I should move to the left. And I'm going to move 4 spaces like it tells me. So if I do that, I end up right here, and I put the -4 here. This is the graph for -3 plus -4, right? So how can I use the number line to help you write -3 plus -4 as a subtraction problem? Well, I know that these operations are inverses. So the graphs should look the same, right? So all I gotta do is come up here and put a dot here, draw my arrow over to here, and then if I'm subtracting, right, I just change it to -3 minus 4. And so this number up here is going to be a +4, right? So my equation, right, her original subtraction problem was -3 minus 4 equal, right? So all I did was keep, change, right? Oh, and I also used the number line to verify it. So I know the answer to number 7. How did I get my answer? Right? Addition and subtraction. All right, and addition and subtraction are inverse operations. Right? So I graph the addition, then graph the subtraction, to start and end in the same place. Okay, I start and do start and end in the same places, and then what I do is write the subtraction equation from that second graph. So my second graph is this one, and it's -3 minus 4, right? And it should, and they're both equal to -7, and that is my answer to both of them. So they should start in the same place. All right. The last thing we're going to do is 8, 9, and 10. Right. 8, 9, and 10 are talking about distance on a number line. Right. So between, what I'd like you to do in your book is between this space and this number, question 8, I want you to draw a number line that starts (5) and -5. It just goes from -5 to 5, right? That's all we need. And now we're going to be talking about distance on a number line. And remember that distance on a number line is absolute value, right? So what is the distance between 3 and 2 on a number line? I'm going to put that up there. Here's 2 and here's 3. That distance is 1 unit. So in this line right here, we should write 1 unit. All right? This one says, what is the absolute value of 3 minus 2? Well, the absolute value of 3 minus 2, and remember that's your absolute value sign, is equal to absolute value of 1, which is equal to 1. All right? Now, they're asking us what's the distance between -3 and -2. Well, if I come over here on the number line, and I use a different color so you can see it, -2 is here, -3 is here. That's still just 1 unit. All right? That's 1 unit. What's the absolute value of -3 minus a -2? Right? Well, I can rewrite that as -3 plus 2, right? And that gives me -1. The absolute value of -1 is just 1. Remember, all absolute values are positive, right? So the answer to this question here is also going to be 1. So if you fill those in, then you have number 8 done. And number 9 is exactly the same thing, only this time we're going to do it below because it makes it easier. This time we're going to do the distance between 4 and 1. Here's 4, here's 1. That distance is 3. All right? We're going to do the same thing over here, -4 and -1. -4, -1, and that distance is 3. All right? So the answer to what's the distance between 4 and 1 on a number line is going to be 3 units. Okay? Then they want to know the absolute value of 4 minus 1. The absolute value of 4 minus 1 is equal to the absolute value of 3, which is 3. All right? Now they ask us what's the difference between -4 and -1. Well, from -4 to -1, it's 3. Then they want to know the absolute value of -4 minus a -1. Right? And we can rewrite that again by keep change as -4 plus 1, again we're doing the absolute value, and that's going to be equal to the absolute value of negative 3, which is equal to 3, because remember absolute value is always positive, since the absolute value is simply how far is something from 0 on a number line. Alright? So now I want you to look at your answers for all the absolute values. We have this one, that's 1, we have that one as 1, we have this one as 3, we have this one as 3. So for number 10, what you need to do is look at the problems, 8 and 9, look at the absolute values and tell me what you notice, right? What do you notice about the absolute value? Absolute value is always positive. Right? Always positive. That's all we're looking for. Make sure we understand that. Okay? The last thing we're going to do for today is the try it another way section before we get on to the homework. And again, your homework's page 13 and 14. Let me arrow this up. Roll it up a little bit. So they want you to write an absolute value expression. Write an absolute value expression that represents the distance between negative 2 and 4 on a number line, and then evaluate the expression. So let's take a look at the number line. Right? We have 0 here. We'll just do negative 4. 1, 2, 3, 4. Positive 4. Right? And let's go ahead and mark it. We have negative 2 right here. So that's negative 2. And we're going to go all the way over to 4. So we want to know how far that is. So all we have to do, absolute value of negative 2 minus 4, right? Minus 4, it gives us the absolute value of negative 6, which is equal to 6. Now what would have happened if you had done this? What would happen if you said 4 minus a negative 2? Would that change anything? Right? Well, you would get 4 plus, this would be 4. Change this to a plus, change that to its opposite, you get 2. Absolute value of 4 plus 2 is the absolute value of 6, which is also equal to 6. So it doesn't matter which way you do it. When you're talking about distance on a number line, you're going to get, as long as you take the difference, right, you're going to get the same final result, right? Now one of them is the absolute value of 6, and one is the absolute value of negative 6, but both of those are equal to 6. All right? And again, thank you for taking the time to look at this video. And I hope that you all feel better and get back in class soon. We miss you guys, and it's a lot more fun when we got everybody here. All right? Until then, I'll see you on the video tomorrow.